Good morning, class, and welcome to the Cretaceous period. Close your eyes for a moment and picture a world unlike our own. It's a humid, lush, and incredibly vibrant place, dominated by giants. We are 66 million years in the past, and this is the age of reptiles, a reign that has lasted for over 180 million years. The non-avian dinosaurs, the big ones we all know and love, are the undisputed rulers of the land. Imagine the mighty Tyrannosaurus rex, a 40-foot predator, stalking through fern-filled jungles. Picture the three-horned triceratops grazing in open plains, and the long-necked brachiosaurus reaching for the highest leaves. In the skies, massive pterosaurs soar on leathery wings, and in the oceans, enormous marine reptiles hunt. The world is a vast, interconnected, and flourishing ecosystem. For millions upon millions of years, these creatures adapted, evolved, and survived everything the planet threw at them: continental drift, shifting climates, and changes in sea level. They were the ultimate survivors. And yet, this magnificent, seemingly invincible era came to a sudden, catastrophic end. Our story today is about that ending. What killed the dinosaurs? Approx. Time 0400. The suspects: gradual decline or sudden catastrophe. For centuries, the mystery of the dinosaur extinction puzzled scientists. Why did they all vanish so abruptly in the fossil record? Early theories suggested a long, slow decline. Perhaps they died out due to increasing competition from mammals. Maybe it was a prolonged period of intense volcanic activity, with massive eruptions spewing enough gas and dust into the atmosphere to gradually change the climate. Indeed, there is evidence that the Deccan Traps, huge volcanic lava flows in what is now India, were active around this time. These eruptions certainly altered the global environment, causing long-term climate change and environmental stress. Some species were already struggling. However, the geological evidence tells a more dramatic story. When scientists look at the boundary between the Cretaceous period and the Paleogene period, the exact moment of the mass extinction, they find a signature of something far more sudden, far more global, and far more violent. Approx. Time 0800. The smoking gun, the Alvarez hypothesis. In the late 1970s, physicist Luis Alvarez and his geologist son Walter Alvarez made a discovery that changed everything. While studying rock layers in Italy that marked the time of the extinction, they found an unusually high concentration of the rare element iridium. Why is iridium important? It's extremely rare in Earth's crust, but is found in much higher concentrations in asteroids and other space rocks. The Alvarez team proposed a revolutionary idea. The mass extinction was caused by a giant extraterrestrial impact, an asteroid slamming into Earth. At first, the idea was met with skepticism, but the evidence kept piling up. Scientists began looking for the impact site. They found it in the early 1990s, the Chicxulub crater, a massive 110-mile-wide impact structure buried beneath the Yucatan Peninsula in Mexico. Analysis confirmed it was exactly the right age, about 66 million years old, and large enough to cause global devastation. Approx. Time 12 o'clock. Ground zero, the moment of impact. The evidence now overwhelmingly points to a single, terrifying day. Imagine a rock between 6 and 9 miles wide, the size of Mount Everest, hurtling through space at tens of thousands of miles per hour. 66 million years ago, it struck the Earth. The energy released upon impact was truly unimaginable, millions of times more powerful than the largest nuclear bomb ever tested. The asteroid vaporized instantly, creating a fireball that incinerated everything for hundreds of miles. The immediate effects were catastrophic. A massive tsunami, perhaps 1,000 feet high, slammed into coastlines. An enormous earthquake, magnitudes higher than anything modern humans have ever recorded, shook the entire globe. But the real killer was the ejecta. Superheated dust, pulverized rock, and vaporized asteroid material were blasted into the atmosphere. As this debris re-entered the atmosphere across the entire planet, it caused a brief but intense global heat pulse. The sky essentially rained fire. Global wildfires ignited, burning forests and consuming life across the continents. Approx. Time 1600. The long shadow, the impact winter. If the initial heat didn't kill them, the aftermath certainly did. The hundreds of billions of tons of dust, ash, and soot that were launched into the atmosphere didn't just fall immediately. They formed a global veil, a thick, suffocating blanket that blocked out the sun for months, maybe even years. This created an impact winter. Photosynthesis stopped. Without sunlight, the world's plants, the base of the entire food chain, died. Temperatures plummeted. The Earth's climate went through a dramatic, rapid cooling, plunging the planet into a deep freeze. Ecosystem collapse. The large herbivorous dinosaurs starved first, as their massive bodies required huge amounts of vegetation. The carnivorous dinosaurs that preyed on them soon followed. The largest creatures, the dinosaurs that had ruled the planet for so long, were simply too big to survive in this new, resource-scarce world. They couldn't find enough food, and their eggs and hatchlings were vulnerable to the freezing temperatures. Approx. Time, 1900. A new beginning. The survivors. The extinction event was devastating, wiping out an estimated 75% of all species on Earth. But it wasn't a total clean sweep. The survivors were often the small, adaptable creatures. Mammals which were small, warm-blooded, and could burrow underground or hide in caves. Crocodilians and some other reptiles, which could survive long periods without food. And most importantly, a small group of avian dinosaurs, birds. Yes, birds are the direct descendants of the dinosaurs, the only lineage that made it through the disaster. The death of the giants created a massive ecological vacuum. Once the dust settled and the climate stabilized, these small, adaptable survivors began to thrive. They evolved to fill the empty niches, and over the next few million years, the tiny mammals diversified, leading eventually to the rise of primates, and ultimately to us. The story of the dinosaur extinction is a stark reminder of how fragile life on Earth can be, and how one single sudden event can forever change the course of evolution. It was the day the world went dark, and the beginning of a whole new chapter. End time, 2000. Optional ending question to continue discussion. What aspect of the impact, winter, the wildfires, the tsunamis, or the darkness, do you think was the most devastating for the dinosaurs? If you liked the video, you can subscribe to the channel. Bye bye everyone.